Earth's cryosphere contains some of the most magnificent and dynamically changing features on our planet. These vast rivers of ice and floating ice shelves play crucial roles in regulating global climate and sea levels. Indeed, these 10 significant ice formations demonstrate the immense scale and crucial importance of the world's frozen regions in our global climate system. As we reveal icy wonders, subscribe to Information Thin, share with adventurers, and comment your glacier questions. Experience a journey through ice and time. Number 10. Swiss Alps Glacier. As the largest glacier in the European Alps, this massive ice stream stretches approximately 23 kilometers through Switzerland's Jungfrau region. The glacier originates from the Concordia Plats, where 3 smaller ice fields converge, creating a distinctive medial moraine pattern on its surface. Scientific monitoring shows the glacier has lost significant volume since the late 19th century, with current retreat rates accelerating due to rising temperatures. The glacier's depth reaches up to 900 meters in some sections, containing valuable climate archives within its ice layers. UNESCO designated the surrounding area as a World Heritage Site, recognizing both its natural beauty and scientific importance. Regular measurements track the glacier's mass balance and movement, providing crucial data for understanding climate impacts in alpine regions. Number 9. Icelandic Ice Cap. Covering approximately 8% of Iceland's territory, this ice cap represents the largest in Europe by volume. The ice reaches thicknesses up to 1,000 meters in some areas, concealing several active volcanic systems beneath its surface. Multiple outlet glaciers flow from the central ice dome toward coastal regions, creating dramatic ice formations and glacial lagoons. Scientific monitoring tracks the ice cap's response to climate variations through mass balance measurements and GPS stations. The region serves as an important research site for glaciologists studying ice-volcano interactions and climate change impacts. Number 8. Greenland's fastest. This rapidly moving glacier discharges more ice from the Greenland ice sheet than any other, flowing at speeds exceeding 40 meters per day. The glacier's calving front extends approximately 6 kilometers wide, where it meets Disco Bay, producing numerous icebergs annually. Scientists observe seasonal variations in flow speed, with acceleration typically occurring during warmer months. The glacier's retreat since the late 1990s has been documented through satellite imagery and field measurements. Research focuses on understanding how ocean temperatures and atmospheric conditions influence the glacier's behavior and contribution to sea level rise. Number 7. Alaskan Retreat. Once extending across the entrance to Columbia Bay, this glacier has undergone significant retreat since the 1980s. The glacier has separated into multiple branches as it receded up the fjord system, increasing iceberg production dramatically. Scientific studies have documented the glacier's thinning and acceleration using aerial photography and satellite observations. The retreat has created new navigable waterways while altering local marine ecosystems. This glacier serves as an important case study for understanding tidewater glacier dynamics and their response to climate warming. Number 6. High altitude battlefield. Situated in the disputed Kashmir region, this glacier represents the highest battlefield on Earth at elevations exceeding 6,000 meters. Military presence since 1984 has created environmental challenges, including waste accumulation and pollution concerns. Despite the high-altitude desert conditions, the glacier feeds into the Nubra River system, eventually joining the Indus River. Scientific access remains limited due to geopolitical tensions, though remote sensing studies monitor the glacier's dynamics. The region demonstrates how political conflicts can impact both scientific understanding and environmental protection of fragile cryospheric systems. Number 5. Antarctic Highway. As the world's largest glacier, this ice stream drains approximately 8% of the Antarctic ice sheet into the Amery ice shelf. The glacier flows through a massive subglacial trough that reaches depths of 2,500 meters below sea level in some sections. Ice flow speeds vary significantly across the glacier's width, with the central stream moving fastest at about 400 meters annually. Scientific research here includes ice core drilling that reveals climate records extending back hundreds of thousands of years. The glacier's stability remains a critical factor in projections of future sea level rise. Number 4. Canadian Accessible. This outlet glacier from the Columbia icefield provides one of the most accessible opportunities for public glacier viewing in North America. The glacier has retreated approximately 2 kilometers since the late 19th century, with markers along the access road indicating former terminal positions. Scientific monitoring includes mass balance measurements and ice velocity tracking using GPS and ground-penetrating radar. Educational programs help visitors understand glacier dynamics and climate change impacts. The glacier's rapid retreat serves as a visible indicator of changing mountain environments. Number 3. Patagonian Giant. Located in Argentina's Los Glaciares National Park, this large valley glacier flows from the southern Patagonian icefield. The glacier terminates in Lake Argentino, where it forms a calving front approximately 5 kilometers wide. Sediment-rich ice gives the glacier's surface a distinctive gray appearance compared to neighboring glaciers. Researchers monitor the glacier's retreat using time-lapse photography and satellite imagery, noting accelerated recession in recent decades. The glacier's accessibility allows for regular scientific expeditions studying Patagonian ice dynamics. Number 2. African Disappearing. Located near the summit of Africa's highest peak, this small remnant ice body has dramatically decreased in size throughout the 20th and 21st centuries. The glacier has fragmented into separate sections as it has retreated, with some portions completely disappearing. Scientific analysis of ice cores from the glacier has provided valuable climate records for equatorial East Africa. Researchers attribute the retreat primarily to atmospheric warming and decreased precipitation. The glacier's disappearance represents a significant cultural and environmental loss for the region. Number 1. Antarctic Concern. This deep channel glacier has attracted scientific attention due to its potential vulnerability to warm water intrusion from the ocean. The glacier flows through a trough that reaches 3,500 meters below sea level, one of the deepest continental points on Earth. Satellite observations have revealed accelerating thinning and grounding line retreat in recent decades. The glacier's configuration creates potential for marine ice sheet instability under certain climate scenarios. International research teams continue to study the glacier using ice-penetrating radar and oceanographic measurements to better understand its future behavior.